Okay, my name is Joe Olson. I'm from Chicago. Trevor, who's also in this room somewhere, and I are the organizers of the Chicago Flink meetup. So we try to get people in Chicago, educate them on Flink, try to get a users group going so we can trade ideas, trade notes, how to solve problems using Flink, and just have a general forum to discuss Flink issues. So a little bit about me and what I do. I work for a tech company that collects, stores, enriches, and presents vitals data for a given patient. So it's a medical device company. Some of the information we collect, heart rates, oxygen levels, respiration rates, all that information that would be interest to the medical community. We collect this information so we can build a predictive model of the patient's state of health. So that's basically what all this data flows into. It's a number we come up with between 0 and 100 that basically measures how the patient's doing. Is the patient getting better? Is the patient getting worse? Who would use this? End users are patients, are pretty much patients at a healthcare facility, and the staff at the healthcare facility would be using this as well. We also have a use case where the patients are at home, so this would be home monitoring. So how do we do this? So data originates from wearable patches. So there's a bunch of vendors out there that have patches you can put on that measure your vitals. We start with the data from there. The data usually coming off those patches, since they're very simple, very low power, are generally waveforms. So we don't get nice even floats or integers off these patches. It's a waveform, binary waveform. So if you think of this programmable logic controllers, it's pretty much a basic IoT type application. We get data in 1 second chunks, and usually that 1 second chunk is between 2K and 4K, or excuse me, 2K and 6K. So that's the general flow we have coming in off these patches that the user might be wearing. And the data we sample maybe, the data we're measuring maybe sample anywhere from once a second to 200 times a second. So in that, the binary waveform we get, we have to deconstruct that, and sometimes we get 200 values out of that, sometimes we get 1 value out of that. And our goal throughout this is to treat data as stream throughout all our data flows. Okay, so let's talk about states in a Flink stream. 6 months ago in Berlin, they were talking about Flink 1.2, which was released in January, and the big improvement there was this idea of we're going to measure state inside of Flink, and we're going to allow you to go in and pull it out externally from Flink. That was one of the hot topics there. So I went home and learned as much about state as I could in Flink. The documentation right now in 1.2 is pretty good. So if you go to the website and read through the documentation. However, my notes here I had written before the 1.2 documentation was formed up. So this is the talk I wish I would have had 6 months ago to bring me up to speed on what all these features are doing, what all these terms mean. So we'll just go over them real quick, and then I'll show you how they apply to our use case. So there's 2 types of state in Flink. There's keyed state, and then there's operator state. Keyed state's the one we're most interested in. That's basically you have a keyed stream coming in, and you have a state space for that keyed stream. So if you have a patient ID, let's say, all the state for that patient would belong to that state space. So if you've got 5 patients, you'd have 5 different state spaces that you can reference. The other state is a little more esoteric. It's we don't use this too much, but it's the operator state. This is stuff built into Flink that allows Flink to talk to Kafka effectively. So in this instance, it's a little different. It's the state here is associated with each of the operator instances rather than something that the user defines. And then both of these states exist in 2 forms. Managed, which is Data Artisans gives you a data structure to use that you can use to track this state. And the other is you can create your own, which is raw, which is basically a user-defined byte array. And you're on your own how you deal with it. So most of our use cases leverage the managed key state. So managed key state, as I said, that was the Data Artisans tools they give you. And these are the 3 tools they give you. They give you value state, which is a single value that can be updated and retrieved. So think of, you've got a patient, you've got a single value associated with that patient. That is what you can use to save data for that patient, synchronize it to disk, and bring it back. We'll talk about that in a minute. So a value state's pretty simple. It can be updated and retrieved. There's two methods for it, which are update and get. There's also a second key state they give you, which is a list state. This is a list of elements that can be added to or iterated over. So this is not just one value, it's a list of stuff. So you can add to it or iterate over it every time data comes in. And then the reducing state is, it's a single value that represents an aggregation of all values that are added to the state. So think of an average, think of a sum, something like that. That would be a reducing state. The data that comes in gets aggregated into a value that is already stored in the state. Okay, states, since we're in a fault-tolerant environment, high availability fault-tolerant environment, there's three ways you can persist state in Flink. When that is, when I say persist, I mean send it to disk so that if there's an error, if there's a situation with the cluster, another node can come in and pick up where the previous one left off. So the three states they give you to work with, the three backends for the states they give you, memory state backend, basically that's the state, anything you're measuring on the patient or anything you're measuring on your stream gets stored on the Java heap. The aggregate state in that case must fit into the job manager, the RAM of the job manager. So if you're holding simple values, as long as your values are primitives that can store in RAM, this is a good choice for your state backend. It's also good for testing. It's because it's fast, it's simple, and you can set it up without too much problem. The other way you can persist data is on the file system. So data held in RAM upon checkpointing will be flushed to disk. So if you're in a high availability environment, you want that disk to be a shared disk so that another node coming in to replace a node that had failed has access to the state that the original node that failed had written. So you can send your states to for testing or for non-production environment to just a regular file system, or in a high availability production type environment, you can send it to HDFS. So if the shared file system, the next node that comes along picks right up where the last one left off. And then the final backend you can use for state is RocksDB, which is a third-party key value store. In this situation, if you choose this as your backend store, all the data in your state is going to be stored and retrieved off disk. So every time you modify your state, you flush it to disk. Every time you read it, you pull it off the disk. And RocksDB is got its own infrastructure to handle all the requests for that. And these will seamlessly, as you'll see in a minute, each one of these states is seamlessly added to a Flink job. Okay, so here's an example of everything we've talked about here. We set up an environment. We set the state backend for that environment. So the state backend, we were talking about the RocksDB or the file system or the RAM, that can be set on the server level in the Flink YAML file, or you can set it on the job level. So an example here is we create an execution environment and we point that execution environment to RocksDB, which is parked on a HDFS store. We then define our stream. And in this case, I just have a very simple stream here. We've got a keyed stream comes in, and we define our key, and then we can define a flat map to operate on that key, and our state will exist within that flat map. So in the box on the bottom, we've got a class that's actually going to process each one of these. Remember, a flat map, every time you get one in, you emit one or zero, or one or more, zero or more elements on the other end. So in this case, we get a data point comes in. What we can do is, I've got defined here, I've got a list state, so we can take some piece of information that came off that data point coming in and add it to the list. So this is pretty much how our state management works within Flink. We would set up a job, and then inside that job, we define a list, a value, whatever. And then while the job is processing, we write to that state. And in this example, the other thing that should probably be pointed out is there's also, if you don't clear the state, it will continue to take up space. So the last line in the bottom box where we have a list state, we clear it under whatever circumstances we want. At that point, the state goes away and we're back to 0. Okay, now queryable state. So queryable state, the queryable state feature in Flink 1.2 refers to a managed state that is accessible outside of the Flink runtime environment. So what we just did is we just set up a way to count things or measure things or grab things. We can do with one call, we could set that up to be queryable, which means we can, outside of Flink, we can go back in and we can pull that out of Flink. So the way you do that is very simply, you set the descriptor for the state to queryable. You say, I want to make it queryable, and you give it a friendly name, which you can query. And then to access managed state from descriptor from outside of Flink, it's very simple, a couple lines of code. You set up a configuration pointing at your Flink servers. You set up a client, and then you go in with 3 arguments. The key, remember the state is based on the unique key on the keyed stream. So we go in with the key. We go in with the job ID that's running this, and that's easily, if you don't have the job ID, you can make a quick REST call to the Flink server to get the job ID based on the job's name. And then the name of the queryable state that you set back at the top of the slide here. So what this allows you to do is external to Flink, say, give me state that's in Flink. Give me something that's Flink is accumulating over time. Give me something that's that I'm interested in, but pull it out of Flink without having to send it to a sink. Okay, so here's a couple more notes. The managed state is created within the Flink runtime context. So when you define the job, you define the state, you define the type of state you have, and it's all managed by Flink's runtime context. Now, to access that state, you have to go through the runtime context. The problem with this is, and I've been talking to Ufuk about this, who is a Data Artisans developer who's working on this. The problem is the queryable state does not work right now cleanly in all cases if you're using the windowing function within Flink. So an example here, I have a standard build a window, set up trigger on that window, set up the rule to fire when the trigger fires, and then send it to a sink. That structure doesn't quite work for the queryable state right now. What it does work for is the data structures, such as a flat map inside of Flink, that are exposed to the runtime environment. So that's where you're limited right now to use it. They're going to change it in the next releases to allow you to query stuff out of a window as it's being accumulated into a window. But right now, you're stuck to a flat map situation, the map situations where one comes in and you can record state on that, pull it out of Flink, external Flink, and then send the data on its way. The 2 notes at the bottom, more complex state management. So when I said initially you can have a list or you can have a value, that value might actually be like a hash map. You can have a hash map associated with state for a, let's say, data point. So if you have multiple things you want to record for that data point coming in, if there's a vehicle coming in and you want to record its average mile per hour, its top speed, that's all achievable through the state management tools they give you. You can set up a map of states inside of Flink that keeps track of different things you're tracking on with the data. The other trick you can do is you can set up different states for different partitions. You can have a state from 0 to X, another state from X1 to Y, another state from Y1 to Z. And as long as you can reference the right state bucket that that's going into, you can pull that out also externally from Flink. Okay, so our use case, now how do we use all these things with the medical device company? We're trying to move from a batch mentality to a stream mentality. So use case one is very simply we use Flink as a ETL. So we get raw data in, we pump it into its to the spot where it rests. So in our case, we go Kafka, Flink, and then an external KV store. We know Kafka scales, we know it's fault tolerant, we know Flink scales, we know Flink's fault tolerant, so that seems to be a very good way to scale moving data as a stream. Use case two, this is the important one. We need to know, given time one and time two, simple time series query, find all places where we have data. So this would be an example of, I give you a list of n integers, and I want to find all the gaps between consecutive integers. So historically, we would always calculate that after the fact on our data store. So we'd go out and we'd query our data store, and we'd calculate that after the fact. Well, if all the data is flowing through Flink now, what we can do is we now calculate this in real time. Every point that comes in, we can tabulate what point in time that data point existed at and update our running list of where our data is. So this is now calculated in real time, served up with Flink, and it's fast and accurate. And because we can pull it out of Flink via the queryable state, we can go in and say if we need information between time 1 and 2 where we have coverage, instead of hitting the data store, the key value data store, we can pull it right out of Flink. And then the third case is given data at, like I said, 1 second resolutions, can we buffer it into X second blobs? So we get a data frame come in, data come in, data come in, data come in. Can we aggregate that into a bigger data chunk and write that once to disk? And then we have to do a read. We don't have to read, sequentially read a bunch of data. So this, the way we're currently implementing this is we're using the windowing in Flink. However, we can't access what's in a window in Flink external yet. So this is not currently in production. So we need the queryable state visibility into the windowing in Flink in order to get this use case met. So then the final use case is what everyone was talking about in Berlin last year, which was, can you replace the external KV store? Can you just replace that with Flink? So would we be able to pull data out of Flink itself without having to store it at rest in a dedicated data store? And if you listen to some of the talks here, there'll be two more talks later this afternoon that will talk about large scale storing data inside of Flink in this manner. So the question is, will Flink be the database going forward? Does it have enough tools right now to manage data as a database? Okay, any questions? Yes?
When you're trying to query keyed state, is there a good mechanism to like list the keys, kind of like a show tables in the SQL way?
No, any key value store is going to have that problem. Getting a list of keys out of this would be difficult. Now, what you could do is set up a secondary store to store keys,
right,
and then you'd have them all in one place. But natively, no, there's no way to get the keys associated with a job easily.
Okay, so you would assume if someone were to build an app on this, they would know what key they're already looking for?
Exactly.
Okay.
And I think that's the rule with any key value store out there, is you got to know what you're looking for rather than searching for it.
Cool, thank you.
Do you have problems related to, say, pipeline upgrades, and when you do that, then access to state is lost?
So if you're running in high availability, so you've got N nodes, N Flink nodes running, as long as the job ID is preserved across the nodes, you're safe. So we do frequent checkpointing.
No, right, but like you upgrade your pipeline and it becomes somehow inconsistent with the old version. And so users then realize and the state is lost. So do you experience those problems? Or?
In that case, okay, so in that case, what we would do, most likely, and we haven't really dealt with that, we've got one in production right now, and we haven't really upgraded it. My guess is we'd start another job that would have its own state defined, and we would most likely refeed all the data we've processed previously into the new pipeline. That would be, I don't know how to move state out of one into the other at this point, other than reprocessing. So I'd have to think about that one a little bit more.
Hi, could you actually talk about the amount of data that you have in Queryable State and then your deployment and how you laid it out? Like the number of resources you give it and how much data you're processing through and how much data you're keeping in Queryable State.
So what we usually do is, our rule of thumb is a given subject will have 180 gig of data a year. That's about what the rule of thumb we use. And then it's just the number of patients you have is the one that represents what your state is. We don't manage all of that state in Flink right now. Most of that's flushed out to the key value store. On the order of what we are storing in Flink, which is the coverage, data coverage, the time coverage, that's on the order of low megabytes per patient. So it's not anything that Netflix is doing. We're much orders of magnitude less than them.
So but like how much, if you were to just give a size for the whole state, like how much do you have out there?
Mid-gigabytes.
What?
Mid-gigabytes. Probably 20 to 50. I've never really measured it, but my guess would be 20 to 50 for the patient load we have and the amount of coverage we have and how we have it partitioned. And I know if you follow the mailing list or you follow some of the talks, you'll know that is baby state compared to some of these other applications.